So we are continuing onward in our test review with question number 7. I did not write this down, but number 7, I have changed the numbers from what they actually gave you. I changed it. I kept the x as a positive integer, so x is greater than 0. I changed it to x mod 3 equals 2, x mod 7 equals 5. Real quick word on what modulus is, because people sometimes just don't understand it. I'm going to do something like this, but I'm just going to make up a number and we'll see what comes out. I'll say 45 mod 7. All right. What you do for this, you do a division. 45 divided by 7 goes 6 times. That's a 42. There's a remainder of 3. That remainder is your modulus. Right? 45 mod 7, had I done it instead of 45, had I done it as a 52 mod 7, 7 larger means this wouldn't be a 6 anymore, it'd be a 7, remainder would still be 3. All these values that differ by 7, these are all equivalent in modulus 7. Right? So if we're doing a mod 7, we could say that any number whatsoever, m, and m plus some integer value of 7, integer multiple of 7, that for those things, they would be equivalent in modulus 7, right? So when we do this, whatever our number for x is, if I just add 3 or 6 or 9 to it, it's still going to have a modulus of 2. Knowing that kind of tips us off as to what the fastest way of just getting this answer would be. And when you're actually taking the test, you do want to be aware that the clock is ticking, and you want to get this answer in as quick a way as possible. So for this one, if I really wanted to do it, I would just say, what might the x be? Mod 3 equals 2. Well, 2 clearly works. 5, 8, 11, etc. Mod 7 equals 5. I would just do this and look for the first number that they hit. Haven't hit it yet, but 5. This answer is going to be a 5. Right. The one that you actually have in the book, different numbers, so who knows. This is the fastest way. That took me 10 seconds. Right? I'm hoping that you'll get something other than just how to answer the question on a multiple choice test out of this. So I'm going to go ahead and complete the process. But because you want to pass the test and put that time into your next questions, this question shouldn't take any longer than about 10 seconds if you just write down what the possibilities are for what they actually gave you. Anyway, for us, what I would do if I'm actually solving this, because they might give us values of like, I don't know, these numbers, they might be in the thousands. Who knows what they might give? I want to be able to make sense of this and do a logical approach. So what I would do is I'd say, well, if x mod 3 equals that, then I know right off the bat that x equals 3 times some integer value plus 2. I'm going to put down k as an element of the integers. And I'm going to leave myself a little bit of a blank space here. Because when I write the same thing down here for the next one, you're hopefully asking, wait a second, do they have to be the same integer? And they don't, so we have to subscript those. So we know that k1 and k2 are both elements of the integers. X has to be that. If x has to be greater than or equal to greater than 0, because it's positive, then I know that x, which is 3k1 plus 2, has to be greater than 0. If I do that, I can use this inequality with the k1 to figure out, to limit my range of values for k a little bit. This k1 would have to be greater than negative 2/3. It's got to be an integer, so it's got to be greater than or equal to 0. And I would do the same thing with the second one. I would know that 7k2 plus 5, we're going to get the same thing out of it. It's just sort of a logical sort of thing. I mean, you get a negative 2/7 and the first integer there is 0. So both of them have to be greater than or equal to 0. So my k's cannot be negative for this. Right, and that just kind of stands to reason. If I'm doing positive values here, that can't be 3. It's got to stop at 2. So if I logic my way through it, we're always going to get non-negative values for the k, right? So our k's have to be non-negative. We just kind of know that going in, right? So what I would do for this thing here is I would look at it and say, I'm going to take one of these things where I have this. If I solve this thing for K1, I have different numbers on that. I did the ones in your book over there and just looking at it going, wait a second. Let's see. Didn't write my second one down. I would know that because the x value equals 3k1 plus 2, and the x value also equals 7k2 plus 5, I know these have to be equal to each other as well. That is a transitive property of math. You don't need to know that, but if a equals b and b equals c, then a equals c, that's kind of what we have. This equals x and x equals that. These two are equal. So anyway, if we do that, I can solve this for either k1 or k2. I'm going to solve it for k1 just because. If I subtracted 2, that would become a 3, so we'd have 7k2 plus 3 divided by 3. Knowing that k1 and k2 both have to be integer values, what I personally would do is just plug in some numbers here for k2. 7 times 0 is 0. Because k2 might be 0 or 1 or 2 or 3. I'm looking for the smallest values. If I plug in a 0, 0 times 7 is 0 plus 3 is 3. 3 divided by 3 is 1. Oh, 0 works. So I can just try those numbers and see which ones give me integer values for both of them. And I would do that in case I had like 3 or 4 or 5 different numbers. I could just go through it in that routine, that sort of organized routine. The smallest value of k2 that works is 0. That yields a k1 of 1. If I plug in a 0 for k2, I get a 5. If I plug in a 1 for k1, I also get a 5 up here. 3 times 1 plus 2 is 5. So x equals 5 is the first number. Like I said, if we just wrote out for this one here, x mod 3 equals 2, it means that x could start with 2 and then just start adding 5 or 3's to it. And I'm just looking for the first number they both run into, that they're in both lists. 5, and start adding 7's to that repeatedly. If I did this, you can get that. For yours, the answers they actually gave you in the book, I mentioned on one of these earlier, you always want to sort of scan the answer choices if you're doing a multiple choice test. There's only one answer that they give you in the study guide for x that has the mod 3 equaling 1. 5 mod 3 is 2. Can't be that. 13 mod 3 is, that's the one. 11 mod 3 is 2. 17 mod 3 is 2. 13 mod, let's see. Yeah, 13 mod 3 is the only one that works. 13 mod 3 is 1. That's the only possibility. And that would be a correct answer for that. So some things, I'm not a big fan of plugging in the answers for doing tests. But if they're going to do a giveaway like that, clock's ticking, you have to manage your time appropriately. So just plug in the answer choices on this one. You ought to be able to get through this one fairly quickly. But that was how you would do it if you actually wanted to do some logic. And that was number 7.